Every fall across the southern United States, giant machines roll into dusty fields and begin pulling millions of tons of hidden food straight from the ground. Row after row, the soil opens, vines flip over, and thousands of shells suddenly appear where nothing seemed visible before. This is not potatoes. It is peanuts, one of America's most valuable crops, feeding snack factories, oil plants, candy lines, and peanut butter production nationwide. But what most people never see is the incredible industrial system behind it. Today, we're stepping inside the supergiant peanut harvest, where America pulls millions of tons from underground in one of the most unusual farming operations on Earth. The peanut story begins months before harvest. Across states like Georgia, Alabama, Florida, Texas, and North Carolina, farmers prepare vast fields covering thousands of acres. The soil must be loose, sandy, and well-drained. Unlike corn or wheat, peanuts require a very specific environment. Seeds are planted in long rows during spring. As the plants grow, yellow flowers appear above ground. But then something strange happens. After pollination, each flower sends a stem called a peg downward into the soil. That peg buries itself underground and begins forming peanut pods beneath the surface. So while the plant grows above ground, the crop itself grows hidden below. For months, farmers monitor the fields carefully. Too much rain can damage roots. Too little water can reduce yields. Pests, weeds, and disease must be controlled quickly. And most importantly, harvest timing must be perfect, because peanuts cannot simply be picked whenever convenient. If harvested too early, the kernels are immature. If harvested too late, pods may separate from the roots and remain buried in the soil. That means a single decision can cost thousands of pounds per acre. When maturity reaches the target window, the harvest begins. And the first machine to enter the field is one of the most specialized in agriculture: the digger. At first glance, it looks like a standard farm implement, but underneath, sharp blades slide below the root zone and lift entire peanut plants out of the soil. The machine shakes off dirt, loosens the roots, and flips the plants upside down so the peanut pods are exposed to the air. As it moves forward, long rows of inverted plants are placed neatly behind it. These rows are called windrows. And this is the first dramatic moment of the season. A field that looked empty now reveals millions of peanuts stretching across the land. Shells cover the rows, dust rises behind the machines, and hidden food becomes visible all at once. But the peanuts are still not ready. Freshly dug peanuts contain too much moisture. If stored immediately, they can spoil, mold, or lose value. So they remain in the field for several days. Sunlight, airflow, and dry weather naturally reduce moisture levels while the vines rest in windrows. This stage is critical. Rain can delay operations. Humidity can damage quality. Storms can destroy timing. That means harvest season often becomes a race against the forecast. Once moisture reaches the proper range, the second phase begins. Now the combine harvesters arrive. These giant machines move directly over each windrow, lifting the dried plants from the ground. Inside the machine, rotating systems shake the vines violently, separating peanut pods from stems and leaves. Powerful fans blow out lighter material, screens filter debris, and clean peanuts begin pouring into onboard storage tanks. The speed is incredible. A modern machine can recover thousands of pounds in a single hour. Across a large farm, multiple harvesters may run side by side from sunrise to dark. As tanks fill, tractors with grain carts move alongside the combines. Without stopping, peanuts are unloaded on the move. Then they are transferred into highway trucks waiting at the field edge. And this is where farming turns into logistics. Truck after truck leaves the farm carrying fresh harvest toward receiving stations and drying centers. During peak season, roads in peanut regions are filled with loaded trailers moving non-stop. At buying points and warehouses, each load is inspected. Samples are taken, moisture is measured, foreign material is checked. Kernel maturity is graded, only approved loads continue forward. Some peanuts go into heated drying systems where warm air is pushed through the shells to reduce moisture safely. Others move into storage structures designed to preserve quality for later processing. These storage sites can hold enormous volumes. Mountains of peanuts in shell-filled bins, silos, and warehouses across the South. And this is only the raw harvest stage, because the real transformation is still ahead. From storage, peanuts move to shelling plants. Here, giant mechanical systems crack the shells open and separate kernels at high speed. Shell fragments are removed, dust is collected. Kernels are sorted by size, color, and quality using optical scanners and grading machines. Some kernels are selected for premium snack markets. Some head to roasting plants. Some go to candy manufacturers. And a huge share goes to peanut butter factories. There, the kernels are roasted in continuous ovens, cooled, blanched, ground into paste, blended for texture, and pumped into filling lines. Thousands of jars per hour can be produced. That means peanuts dug from underground just weeks earlier may soon appear on grocery shelves across America. But the system wastes almost nothing. Peanut shells are valuable byproducts. They can be used in animal bedding, landscaping products, fuel systems, absorbents, and industrial filler materials. Peanut vines may be baled for livestock feed or returned to the soil. This makes the industry more efficient and profitable. Technology has pushed production even further. Modern tractors use GPS guidance for straight rows and reduced overlap. Yield monitors track field performance. Soil sensors help farmers manage irrigation. Storage systems use automated fans and moisture controls. Processing plants use cameras, robotics, and data analytics to improve grading accuracy. Every stage is faster, cleaner, and more precise than ever before. Still, machines alone cannot guarantee success. Farmers must watch weather windows carefully. A week of rain during harvest can delay digging and lower quality. Hot, dry winds can overdry vines. Labor schedules, fuel prices, transport timing, and market prices all influence profit. That pressure is part of every season. And perhaps that is what makes peanut harvest so fascinating. Unlike corn standing in plain sight or wheat waving across open land, peanuts stay hidden underground until the final moment. Months of work remain invisible. Then, in a short seasonal burst, giant machines uncover millions of tons at once. From sandy fields in Georgia to food factories across the nation, the journey is massive, coordinated, and highly efficient. It is farming, it is logistics, it is manufacturing, and it all starts beneath the soil. In the supergiant peanut harvest, America does not simply grow peanuts. It reveals them, dries them, moves them, processes them, and transforms them into one of the country's most iconic foods. If you enjoyed this deep dive into one of the most unusual harvest systems in the world, make sure to like, subscribe, and hit the notification bell so you never miss our next look inside the giant industries powering everyday life. Thanks for watching. Every year, hundreds of millions of tons of grass are cut, collected, and transformed across massive farms and industrial facilities. What looks like simple green fields is actually the foundation of a powerful hidden system, one that feeds livestock, generates renewable energy, and even returns nutrients back to the soil. But here's the surprising truth. Grass isn't just animal feed, it's one of the most efficient renewable resources on Earth. In some regions, a single acre can produce multiple harvests per year, creating a constant flow of biomass that fuels an entire agricultural economy. Today, we're stepping inside the supergiant grass industry. where millions of tons of grass are harvested, processed, and transformed into food, fuel, and fertilizer in a mind-blowing circular system. Grass may seem ordinary, but on an industrial scale, it becomes something extraordinary. Across vast farmlands, specialized grass varieties like alfalfa, ryegrass, and napier grass are cultivated for maximum yield. Unlike traditional crops that are harvested once a season, grass can be cut multiple times per year, sometimes up to 6 or 7 harvests depending on climate and irrigation. This rapid regrowth makes grass one of the most productive biomass sources available. In some high-efficiency farming systems, a single hectare can produce over 50 tons of fresh grass annually. Multiply that across millions of acres, and the scale becomes almost unimaginable. The journey begins in the fields. At peak growth, fleets of high-powered machines roll across the land. Mowers with wide cutting decks slice through dense grass at high speed, laying it down in neat rows called windrows. Behind them, tedders and rakes spread and align the grass to optimize drying and collection. Timing is critical. Grass must be harvested at the right moisture level to preserve nutrients. Too wet and it can spoil. Too dry and it loses nutritional value. Farmers rely on weather data, sensors, and experience to make precise decisions. Once cut, the grass follows 2 main paths: drying into hay or processing into silage. In the hay process, the grass is left in the field to dry under the sun. Over several days, moisture content drops from around 70% to below 15%. Large balers then compress the dried grass into tight rectangular or round bales. These bales can weigh anywhere from 20 kilograms to over 500 kilograms each, depending on size and type. Hay is one of the most important feed sources for livestock, especially during winter months when fresh pasture is unavailable. Millions of tons are stored, transported, and traded globally. But hay is only part of the story. For high-energy feed, farmers turn to silage, a completely different process that relies on fermentation instead of drying. Freshly cut grass is chopped into small pieces by forage harvesters, powerful machines capable of processing hundreds of tons per hour. These machines blow the chopped material into trucks that transport it to storage sites. At the storage facility, the grass is packed tightly into large silos or bunkers. Heavy tractors drive over the piles, compressing the material to remove oxygen. This creates the perfect environment for anaerobic fermentation. Over the next several weeks, natural bacteria convert sugars in the grass into lactic acid, preserving the material. The result is silage, a nutrient-rich, high-energy feed that can be stored for months or even years. Silage is the backbone of modern dairy and beef production. A single large dairy farm can consume tens of thousands of tons of silage every year, feeding hundreds or even thousands of cattle. But what happens beyond animal feed is where things become even more fascinating. Not all grass is used for feeding animals. Large volumes are directed into energy production systems. In biogas plants, grass and agricultural residues are fed into massive sealed tanks called digesters. Inside, microorganisms break down the organic material in the absence of oxygen, producing methane-rich biogas. This gas can be used to generate electricity, heat, or even upgraded into renewable natural gas for use in vehicles and pipelines. A single biogas facility can process tens of thousands of tons of grass annually, producing enough energy to power entire communities. What remains after digestion is called digestate, a nutrient-rich material that is far from waste. Digestate is separated into liquid and solid components. The liquid fraction is used as fertilizer, returning nitrogen, phosphorus, and potassium back to the soil. The solid fraction can be used as compost or soil conditioner. This creates a powerful cycle. Grass grows from the soil, is harvested and processed, then returns to the soil to support the next generation of crops. In addition to biogas, grass can also be converted into solid fuels. In biomass facilities, dried grass and residues are compressed into pellets or briquettes. These fuels can replace coal in industrial boilers and heating systems, reducing carbon emissions and dependence on fossil fuels. Some advanced systems even convert grass into biochar, a stable carbon-rich material produced through pyrolysis. Biochar improves soil health, increases water retention, and locks carbon into the ground for long periods, helping combat climate change. The industrial systems behind grass processing are highly optimized. Conveyor belts move chopped material continuously. Sensors monitor moisture, temperature, and fermentation conditions. Automated systems control feeding rates, compression, and storage. Everything is designed to maximize efficiency and minimize waste. And that's the most remarkable aspect of the entire system. Nothing is wasted. Every part of the grass has a purpose. Fresh material feeds animals. Excess becomes energy. Byproducts return to the soil. Even emissions are captured and reused in advanced systems. This is what makes the grass industry a true example of a circular economy. On a global scale, the impact is enormous. Grass-based systems support livestock industries that feed billions of people. They generate renewable energy that reduces reliance on fossil fuels. They maintain soil health and agricultural productivity. As demand for sustainable solutions grows, grass is becoming more valuable than ever. Researchers are exploring new ways to use grass for producing bio-based plastics, advanced fuels, and even building materials. Innovations in harvesting technology, fermentation processes, and energy systems are making the industry more efficient every year. From the outside, a field of grass may look simple, but behind it lies a complex interconnected network of machines, processes, and systems working together at massive scale. It's a world where biology meets industry, where nature becomes fuel, and where waste becomes opportunity. If you enjoyed this deep dive into one of the most overlooked industries in the world, make sure to like, subscribe, and hit the notification bell so you never miss our next exploration into the systems that keep our planet running. Thanks for watching, and stay curious. More than 350 million tons of corn every year, more than any other country on Earth. Corn has quietly become one of the most powerful forces behind the American economy. But here's the part most people never realize. Only a tiny fraction of that corn is eaten directly by humans. Instead, the vast majority disappears into a massive hidden system that turns golden kernels into animal feed, fuel, sweeteners, plastics, and thousands of everyday products. Today, we're stepping inside America's supergiant corn network, where endless harvests flow through silos, factories, railroads, and refineries in a mind-blowing process that feeds livestock, powers vehicles, and sustains modern industry. Before we dive in, don't forget to like, subscribe, and turn on the notification bell so you never miss our deep dive documentaries into the industries that quietly power the modern world. Corn might look like a simple crop, but in the United States it is more like raw industrial biomass. Vast fields stretch across the Midwest, especially Iowa, Illinois, Nebraska, Minnesota, and Indiana, forming what is known as the Corn Belt. Modern hybrid seeds, GPS-guided tractors, irrigation systems, and advanced fertilizers allow farmers to produce extraordinary yields.